Multiplying rational expressions. Rational expressions are things that look like fractions, and when we multiply them, we can multiply the numerators together, and we can multiply the denominators together. The problem is if I start multiplying straight across here, I'm going to get something that's much more complicated and not as easy for me to simplify. So the process that I want to use is to start by factoring each of the different components that I see. I'll start with the fraction on the left and factor the numerator here. This is going to factor into x plus 5 times x plus 6. Moving down to the denominator there, we'll have x plus 2 and x plus 3. Let's go to the next fraction. That factors into x plus 3 and x plus 4. And then the denominator there is x plus 4 times x plus 4. All right, so these are my two fractions that are being multiplied together. So as I said, I can multiply across, so I can think of this as just one big fraction. And so that'll allow me to cancel any factors that are identical in the numerator and the denominator. It looks like I have a pair of x plus 3's that can cancel. And then I also have a pair of x plus 4's that could cancel, missing a parentheses there. That looks like all that can cancel. And then what's left over is x plus 5 times x plus 6, and then x plus 2 times x plus 4. This is my final answer. Now you may be tempted to multiply this out, but as we get further into thinking about the graphs and what these functions look like, it's actually easier for us to think about x-intercepts and places where the graph, where we can't plug x values in, values that aren't in the domain, if we leave things in this factored form. So I'm going to leave this in the factored form for our final answer. Let's move on to example B. Following the same idea we just did, we'll start by factoring each of the polynomials that I have. So first I've got, let's see, c plus 6 times c minus 4. For the denominator of that fraction, we'll have c plus 6 times c plus 6. Moving up here, we have c minus 4 and c minus 6. And then here, that looks like c minus 4 times c minus 4. Okay. So again, this is just like one big fraction when we multiply everything together. So I'm going to look at anything that's exactly the same in the numerator and the denominator that can be canceled. We've got some c minus 4's. Well, here's another c minus 4. And then this c plus 6 and this c plus 6. So it looks like for final answer here, we're getting c minus 6 over c plus 6. If I have two fractions, let's say 1/2 divided by 3/4, I can rewrite this as 1/2 times 4 over 3. I take the second fraction and I take its reciprocal. 4 over 6 would simplify to be 2/3. So when we have a division problem, what we're going to do is take the second fraction here, take its reciprocal, so switch numerator and denominator, and then change this into a multiplication problem. So let's rewrite this. So I'm leaving the first fraction alone. Now I'm going to change the operation to multiplication. And then for the second fraction, I'm going to switch the numerator and the denominator. So now this looks like the problems we were doing just a minute ago, where we want to factor each of the numerators and denominators as much as we can. So let's see, this will factor into 3x plus 4 and 3x minus 4. That numerator is a difference of squares. I need to think about this denominator here. Let's see. Need to do some side work. 3 times negative 28. Negative 84. Oops. So let's see, negative 84. I can do 1 times 84, 2 times 42, 3 times 28, 4 times 21. I think I'm going to go with 4 and 21. I want them to be 17 apart. One of the factors needs to be positive and one needs to be negative. So this is a lot of side work over here. I think this is going to be minus 4x and plus 21x. So we'll have 3x squared. I need to split up the middle term. I'm working on this guy right here. Minus 4x plus 21x minus 28, and then I'll factor by grouping. I'll group these, and I'll group these. So this is a 3x, x minus 4. I want this to be x minus 4. And so I'll put a plus. Made a mistake back here. Let's go back. I'm bringing out an x, and I have 3x minus 4. 3x minus 4. I'm going to bring a 7 out. There we go. That makes sense. Okay. So this is x plus 7 and 3x minus 4. All right. That was a lot of work to get this. X plus 7, 3x minus 4. All right. Moving upstairs to this guy, we have x plus 7, x minus 2. We've got to do more side work over here. All right, let me move this over. I'm going to pause and move this over. I just moved that side work out of the way so I could do some more side work. So now I'm focused on this one. I need to do 3 times negative 8, which is negative 24. So I'm going to have one positive number and one negative number. I can get 1 times 24 or 2 times 12, 3 times 8. I think I want 4 times 6. I want the 4 to be positive, and I want the 6 to be negative. So I'm going to split up the middle term and then factor by grouping these and grouping these. So we'll bring an x out to the front, and we have 3x plus 4. I want this to also be 3x plus 4. So I would have needed to bring a negative 2 out. All right, so this is x minus 2, 3x plus 4. Okay, I think I've gotten everything factored now. And now, just like we did before, we want to find anything that matches that can cancel. So let's see, I've got an x plus 7 and an x plus 7. 3x plus 4, 3x plus 4. Hey, is everything going to cancel? X minus 2 and x minus 2. Wow, I am flabbergasted. It looks like this is just going to end up being 1 for my final answer. I'm going to need to check that to make sure. All right, I just checked it and it's correct. Very cool.